starting with number 3. And we could just take 3 to the third and 3 squared, and 3 to the third would be 27, and 3 squared would be 9. We could just multiply them together, and we could find what we want, but we do want to start understanding and practicing those properties of exponents. So let's do that. That'll be, since they have the same base, they're both 3 raised to different powers, and you're multiplying them together. That'll be 3 to the 3 plus 2, add those exponents. That's 3 to the 5th. That's 243. Now let's do number 8. That's 3 fifths to the 4th. Well, there's a property that tells me I can take 3 to the 4th over 5 to the 4th. Okay, and it would be really great for you if you understood why, not just that you can do it and how to do it, but why you can do it, why you can just give 3 and 5 their own exponents of 4. So watch the intro video if you haven't, or if you don't understand why this works. But 3 to the 4th will turn out to be 81, and 5 to the 4th is 625, and that's it. Okay, number 9, that's 2 sevenths to the third, negative third. Okay, so remember the very end of the last video, I just wanted to add really quickly that if you have a fraction to a negative exponent, you can just take the reciprocal of that fraction and make the power positive. Now we can do 7 to the third over 2 to the third, which is equal to 343 over 8. All right. How about number 14? It's 1/2. And that 1/2 is raised to the negative 5, and that is raised to the 2, to the second power. So we'll address this one step at a time, starting on the outside. That's a good rule of thumb. On the outside, you see this squared. Okay, so what's being squared? This is being squared. So when you raise a power to a power, it's called a power of a power, and you multiply those powers together. And then we said in this problem right here, we have a fraction to a negative power, so let's make it 2 over 1 to the positive 10. That's just 2 to the 10th, right? We don't need to say over 1. That's just kind of redundant. And 2 to the 10th is 1024. Okay. Now, something we didn't specifically talk about in the intro video is something called scientific notation. And I try to think long and hard about what the importance of scientific notation is. It's important in science, right? If you could look at a really small bit of material, like just a few, liters or so of say a gas or a liquid, and if you use that particular molecule's molarity and try to figure out how many molecules are in that much of a sample, it turns out to be a lot. And we express these really large numbers and even really small numbers with scientific notation. So to show you why we would maybe want to use this, let's look at an example of a polynomial. Right, we talked about what a polynomial is in the previous video, just a brief snapshot of that. Let's say that this is a polynomial. This is definitely a polynomial that's, it's a reasonable polynomial. It's take a number and raise it to the 15th power. The thing about polynomials is they can get rather large with a relatively small input. So let's put in here a 5, f of 5. That's 5 to the 15th. So let's see what we would get. We'll turn on our calculator. Get out of there. Get out of there. Oh, let's just clear it out. So 5 to the 15th. And look what the calculator reads. 3.05 and so on. E10. What does that mean? So the calculator means this. It means to say 3.0517. Let's just round up to 6. Okay, we'll go up to 5 decimal places. It means times 10 to the 10th. Okay, this little e thing, it means times 10 to the, and then it gives you the exponent. Okay, it's saying I'm using scientific notation here. Okay, so I spontaneously decided to pause the video and research why e is used here. And for one thing, the reason why it doesn't write it out as scientific notation is because the resolution of the screen just isn't very convenient for that. It doesn't work out very well. So they put the e there, and that just stands in the place of times 10 to the exponent of, right, e, this e. It's, no, this is, let's do this. The e here is saying times 10 to the exponent and dot 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 the exponent, whatever number follows. Set to the e is just standing in that place because that's not very convenient. It's the resolution of the screen doesn't work very well to actually write this out. And the reason it's the letter e, it just stands for exponent. The exponent of 10 will be that. So it's a little why. I just, if possible, I like to know why things are the way they are. And there you go. You can know. It's because it stands for exponent, and we just can't write this very well on the screen. So here's the thing. At least in my class, I don't want to see this written on your papers. Da 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 E10. That's, I mean, no, don't do that. So now let's talk about what this actually means. So if you see an e, just understand it means times 10 to the, and write that exponent right there, whatever that number is. What does that mean? Well, it means, so this is a shorter way of writing this, and this 10 to the 10th is a shorter way of writing this. Okay, this number is, when you raise 10 to the whatever power, it's just 1 with this many zeros, so this is, okay, so it's this number, it's 10 billion. So it's this 3.05176, and you know, you can keep going, times 10 billion. Okay, 10 billion has 10 zeros. What happens when you multiply a number by 1 with 10 zeros? You move the decimal place over 10 places. So this number really is, sorry, shouldn't have put a decimal there. So we're going to move this decimal place over 10 places. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So this represents this, which means really this. Okay, it means that we have this really large number, and when the numbers are this large, you can see the room for the calculator to give you an answer is limited. So when it gets beyond that, it goes into scientific notation. Okay, so that's a little rundown on scientific notation. So let's do some problems in which we need scientific notation. And the first will be number 15. 15 says 4.2 times 10 to the third times 1.5 times 10 to the 6th, okay? So the scientific notation is just a shorter, more convenient way to write very large or very small numbers. These ones are very large. If you multiply this by 10 to the third, 10 to the third really is 1,000, and so you'd move this decimal place to the right 3 places. In this example, you would move the decimal place to the right, since 6 is a positive number, to the right 6 places. Now we're not going to do that, we're going to leave it in scientific notation. We're going to multiply this all together and write it as a single number in scientific notation. So look what we have here. We have 4.2 times 10 to the third times 1.5 times 10 to the sixth. Everything's being multiplied together. Even though we have parentheses here, there's no need to really have parentheses. Everything's just getting multiplied. So, this would be the same as writing 4.2 times 10 to the third times 1.5 times 10 to the sixth. Okay? And there's the commutative property, says we can multiply 4.2 and 1.5. So let's do that. 4.2 times 1.5. 6.3. So we have 6.3 times 10 to the what? We have 10 to the third times 10 to the sixth. So we're just going to add those together, 10 to the ninth. So 6.3 times 10 to the ninth is a single number in scientific notation, rather than these two multiplied together. Okay, so now let's do 19. We have 2.1 times 10. 10 to the negative 4. And that is raised to the third. Okay, let's talk about this really quickly. Hopefully really quickly. 2.1 times 10 to the negative 4. Let's talk about what that negative means. Well, we know what negative exponents mean. That's 2.1 times 1 over 10 to the positive 4. Okay, that's 1 over 10,000. So 2.1 really divided by 10,000. What does that mean if we divide by 10,000? Hopefully you've seen that before. You know that if you divide by 1 with a certain number of zeros, with 4 zeros, you would move the decimal place to the left that many places. So this would just be, since it's a negative, it would be a fraction like this, and when you divide by 1 with a certain number of zeros, you just move to the left that many zeros. So we will move over 1, 2, 3, 4. We move 1, 2, 3, 4 decimal places to the left, and that's what this number is. Okay, so that's what a negative exponent means in scientific notation. So positive exponent, move to the right. Negative exponent, move to the left. All right, and so now we're going to use the properties of exponents. You got 2.1 to the third times 10 to the negative 4 to the third. Right, that's power of a product. And so 2.1 to the third, let's find out what that would be. 9.261 times 10 to the what? What do we do with these two exponents? When you raise a power to a power, you multiply them, so you get negative 12. So 9.261 times 10 to the negative 12. So if we wanted to know what this was, or see what it was, we would move this decimal place 1, 2, 3, 4, all the way down to 12 places to the left. Okay, really small number. 12 decimal places is very, very tiny. And it's just more convenient to write it with scientific notation, and so we do. That's why we do it. Number 20. 4.0 times 10 to the third, and that whole thing's raised to the fourth. So again, each of these will get its own exponent, times 10 to the third to the fourth, 4 to the fourth, 256, 256, times 10 to the what? To the 12th. Okay, so here's a rule about scientific notation. You only want to have one number to the left of the decimal point. And here we have the decimal point would be right here. We have 3 numbers to the left of the decimal point. So we need to change this. We need this to be not 3 numbers, but just 1 number. So why don't we just move this guy over here? we'll write 2.56, right, rather than 256. But 2.56 is not the same as 256, so we're going to use scientific notation to say, if you really want to know what this number is, move it to the right 2 places. Move the decimal to the right 2 places. That would be times 10 to the second. Right? If we multiply this by 10 to the second, it means move it to the right 2 places, and you'd get 256. Okay. So this is the same as 256, and we're taking 256 multiplying it by 10 to the 12th. So now we have 2.56 times 10 to the 2 plus 12, the 14th. All right, so there's an example of when we needed to, once we carried out all the operations, we discovered we need to still have this in scientific notation, which 256 times 10 to the 12th is not. So we fixed that right nice. All right, number 22. 1.1 times 10 to the negative 3 over 5.5 times 10 to the negative 8. Okay. So we can really just take the number parts and divide them, and take the 10 to the exponents and divide them. If you're not convinced that you can do that, just think, ask yourself if what I'm about to write, or if what I'm writing is the exact same thing as what we just looked at. Is that the exact same thing? And it is. We would multiply straight across, and that's what we would get, 1.1 times 10 to the negative 3, and likewise in the denominator. So here we just have two numbers divided by each other, 1.1 divided by 5.5. So what's 1.1 divided by 5.5? 0.2. So we got 0.2 times 10 to the, what do we do with these exponents? Well, we take negative 3 minus negative 8, right? Because that's, if we're dividing and they have the same base, then we would subtract the exponents. So 0.2 times 10 to the negative 3 plus 8, so that's 5. And this is not in scientific notation. In the same way that in the previous example, 256 was not in scientific notation, 0.2 is not in scientific notation. We want to move this over to the right one so that we have 2.0. We need to have one number to the left of the decimal place, and we didn't here. But really this, we can't just change it to a 2. We need to, tell the person that we might pass this piece of paper along to that if they really want to know what this number is, they need to move the decimal place from here to there, one decimal place to the left. So that's times 10 to the negative 1. Okay, so this represents 0.2, and we're multiplying that by 10 to the 5th. So we have 2.0 times 10 to the, well, we just add these exponents together because they both have the same base of 10, and so we just add their exponents, so that would be a total of 4. So 2.0 times 10 to the 4th. All right. So one of the most important things to note is if you come upon a number like this, what does it mean? That's the important thing. It means times 10 to the, this number here, times 10 to the 10th. Okay, let's try 5 to the 16th. Okay, now it's to the 11th power, times 10 to the 11th. So I never, ever, 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 ever want to see e to the whatever, or e11, or anything like that. Remember that e represents times 10 to the. All right, so make a note of that. Put it in your brain forever. Yeah, just remember that means we're using scientific notation here. Now, let's move on to number 24. Okay, so this is where this section, and really, not so much this section, that's not the curriculum, it's the properties of exponents. This is where really the rubber meets the road. This is where you have to know your properties of exponents to manipulate expressions like this. And as these expressions get more complicated and as we incorporate these properties into other problems, and these properties are not our main focus and it's just assumed that you know them, it's just going to get more and more important that you understand these. So let's work hard at understanding them, especially when they're in fractions. Fractions seem to throw people the most. So let's see, what would we do here? We've got a base of w and another base of w. We're dividing them. So this is where we subtract the exponents. Make sure you do that in the right order. Right, -2 minus 6. So it's the exponent of the numerator minus the exponent of the denominator. That's w to the -8. Okay, we don't want to leave that negative. The only time you would leave the exponent negative, consistently, would be in scientific notation. That's the only time. Otherwise, we'll make sure to write this as 1 over w to the 8th. Right. 25. 2 squared times y to the 3rd. And all of that is raised to the 5th. Alright, so this is something times something else, and that product there is being raised to a power. When that's the case, then each of these parts of the product get their own exponent of 5. So y to the 3rd gets raised to the 5th. So this is 2 squared to the 5th. So we're raising a power to a power. That's when we multiply them. And again, we multiply these two powers because we're raising a power to a power. So now this is to the 15th. 2 to the 10th is 1024. Y to the 15th. All right. So if you thought that it was a clever shortcut in the first part of this homework to just throw it in your calculator and see what number comes out, okay, so you did get the right number, but now you cannot do that. You cannot just throw this in there and have this come out. And even if you could, you just shouldn't. Yeah, you just shouldn't. You should practice. Number 30. X to the -1 times y squared over x squared times y to the -1. All right. So, at the very end of the intro video, I talked about fractions and negative exponents, and we came to the conclusion that if you're multiplying a bunch of numbers together, it's important that they're multiplied together. If we started adding, that would be a completely different thing. So let's not let ourselves get tricked by that. So it's all multiplied together, so that's good. And we have negative exponents. So what do we do with those negative exponents? This guy is x to the -1, so that's going to come down into the denominator and be x to the +1. Then we have x to the +2, and well, this y is to the -1, so it's going to come up here and have a +1 power, and this y here is y squared. Okay. So remember, if you have a fraction, you have negative exponents, just move them so that they're positive, I think is an easy thing to do. We'll do it, we'll also do it a different way too in just a second. So now we have, this is just too much. Let's get rid of that. So what do we do with these exponents? We add them together. Y to the 3rd over x to the 3rd. All right, let's try that in a little bit of a different way. Just use a different set of properties. How about, in case you might have trouble seeing this, but we can just let the x's interact with each other and the y's interact with each other separately, because if we multiply these two fractions together, they wind up being this fraction. So we can just treat this as its own little thing, and this is its own little thing. We can have the x's interact and the y's interact. So now we have two fractions. We have the same base of x. So what do we do with we have the same base and we have subtraction, or division. We have the same bases and we have division. We do subtraction. We subtract their exponents. So -1 minus 2. Okay, then we're going to multiply that by y to the 2 minus negative 1 power, right? Because same base of y, and they're being divided, so we subtract their exponents. So we have x to the negative 3 times y to the positive 3, 2 plus 1. And this is a negative 3, so we'll make it 1 over x to the third times y to the third. And that's just y to the third over x to the third. Right? But I wouldn't be able to do that if I couldn't fluidly work with my properties of exponents. It's very important. Okay. Next. 34. Or z to the third times 8z to the 7th over y squared. Okay. So we have two fractions here. Why don't we just multiply everything together? We'll get straight across here 8y to the 11th z to the 7th. In case you're wondering why I've written it in this order, I like to write, and typically people will write numbers first, then you'll get to your unknowns, and you'll write them in alphabetical order. So just in case you were curious about that at all. All right. So here we've got 8 divided by 4. 8 divided by 4 is 2. Okay, that'll be up there in the numerator. Then we'll have, well, let's do it this way. 8 divided by 4 is 2. Y to the 11th divided by y to the 2nd. That'll be y to the 11 minus 2, right? Same base. Subtract their exponents because we're dividing. Times z to the 7 minus 3. That's 2 times y to the 9th. That's a 9 times z to the 4th. 2y to the 9th, z to the 4th. 35. Where did we go? Okay. X squared times y to the negative 3 over 3y squared times y squared over x to the negative 4. And we just put everything together, these two fractions together. So we get x squared times y to the negative 3 times y squared over 3x to the negative 4 y squared. Okay, well, we get these two y's here, so let's put those together. We get x squared times y to the, well, we just add these two exponents together, so this would be a negative 1. That's 3x to the negative 4y squared. So this will be, all right, so we got a 1 up here, right? So 1/3, that's 1 divided by 3. X squared divided by x to the 4, so we'll do x to the 2 minus negative 4 times y to the negative 1 minus 2. Okay, so this is 1/3. This would be 2 plus 4, so that's 6, x to the 6th. And then we have y to the negative 3. And then we need to change that a little bit. We have 1/3 x to the 6th times 1 over y to the 3rd. And this looks messy. Why don't we just have it as one single fraction? So we could write this as over 1 if we wanted to. So we have x to the 6th over 3y to the 3rd. Okay, so there you go. Applying those properties. Let's do one more. We need to go up because we've run out of room down here. One more, and that'll be number 43. It's a bit of reasoning. I like these reasoning problems. I don't often assign them. But to me, reasoning means you were not told explicitly how to work out this problem, but you have all the tools that you need, all the understanding that you need in order to complete it. So what it's saying is what would go in place of this question mark so that these two sides were equal. For these two things to be equal, we would need, what's equal to x to the 15th y to the 12th z to the 8th? X to the 15th y to the 12th z to the 8th. What would need to be on the other side of this equal sign so that both sides are equal? This should have been 15. Well, it would need to be exactly the same thing. Y to the 12th, z to the 8th, right? So what would we need to multiply by in order to get this thing to look like this thing? Well, let's look at the x part. We would need to multiply the x by something that would result in an x to the 15th. Okay? Well, x to the 4th times, x to the something needs to be equal to x to the 15th, right? We need that part of the question mark needs to fill this in. So what would we put there for the exponent? Well, what would we add to 4 to get to 15? We would add 11. Right? We need an x to the 11th in there. Okay, so that takes care of the x part of it. Now how about the y? We need to multiply y to the 7th by y to the something in order to wind up with y to the 12th. So what would we put in this exponent? We need to add something to 7 to get to 12, and that would be 5. How about the z? We need to multiply z to the 11th by something, by z to the something else, and that needs to wind up being z to the 8th. Okay, so we need to go from 11 to 8, so we need to take away something. We need to subtract something. We need to subtract, what, 3. So we'll do z to the negative 3. So these guys right here, that's what we need to multiply by in order to take x from the 4th to x to the 15th and so on. So question mark needs to be x to the 11th, y to the 5th, z to the negative 3. So if we multiply this by that, we will wind up with that there. So if we multiplied this by this, we would wind up with that. All right, that'll do it for 5.1. Thanks for watching.